Okay, here's another example of the chain rule. And again, it's a question from the course manual. And the function is given as f of x equals the square root of x plus 3 all over x minus 2. And again, a little bit more algebraic, but we can rewrite this essentially as x plus 3 all over x minus 2 to the power of 1/2. And really this is a simplified form. This is the same as y is equal to some function u of n. In this case, u is a rational function, x plus 3 over x minus 2, and n is a fraction 1/2. And we know the derivative of this function right here, y prime if you wish, is n u to the n minus 1 times du, or simply u prime. And that's shorthand notation for the chain rule. So we're going to find the derivative using these functions, these terms. So the derivative, f prime of x, is equal to 1/2 of x plus 3 all over x minus 2. You subtract 1, so it's the negative 1/2. And then it's the derivative of this term. Now, feel free to go ahead and differentiate it right here. I'm going to put the step in, and you certainly can too. But you can go ahead and apply the quotient rule directly here. I'm just going to put in the notation here. And the notation varies. You can use, d over dx, y prime, or prime. I mean, any of these are perfectly okay. So continuing on, we know that the derivative is 1/2 x plus 3 all over x minus 2 to the negative 1/2. I will simplify that in a little bit. And now I need to find the derivative of this function here, and it's a quotient, so we'll apply the quotient rule. So it's x minus 2, the bottom term squared if you wish. It's the bottom term times the derivative of the top term. Now again, go ahead and differentiate here if you wish right away. I'll put the extra step in. Minus, sorry, that's going to be plus 3, minus the top term, which is x plus 3, times the derivative of the bottom term, which is x minus 2 prime. So that essentially is the derivative. And we'll simplify it a bit further. And what I'm going to do with the first term is rewrite this as 1/2 as x plus 3 to the negative 1/2 all over x minus 2 to the negative 1/2. And I'm just going to do that so it would be easy to simplify when you go through it. And again, here I got x minus 2 times 1 if you wish, minus x plus 3. Derivative of this term, of course, is simply 1, all over x minus 2 squared. Now, a common error is for students to cancel the x minus 2 terms. That's an algebraic mistake. Just be a little careful with that. So what I'm going to do now is rewrite this. And I'm going to bring this term down. And essentially what's going to happen is that we're going to have a lot on the bottom. Well, the numerator, first of all, I'm going to have x minus 2 minus x minus 3. I'll have x plus 3 to the power of 1/2 and x minus 2 to the negative 1/2 and x minus 2 squared. These terms are going to combine, so I'll left them alone. And if you continue on, the x's will cancel. The x's cancel, and I'm going to have on top negative 5. And in my denominator, I've got 2. I've got x plus 3 to the power of 1/2. And when I combine these terms here by adding exponents, I get x minus 2 to the power of 3 over 2. And that's fine for your final answer. You can change it to radical form if you wish. That's how we simplify. And by the way, in radical form, if you want, it's going to be negative 5 over 2 square root of x plus 3 times the square root of x minus 2 cubed. And that is a derivative of that function. And that's example 6 in the course manual.